On page 121, I gave you this fact. The nth root of a times the nth root of b is the nth root of ab. One can use this property to multiply radicals. Notice to multiply radicals, you only have to have the same index. To add or subtract them, you had to have the same index and the same radicand. But to multiply radical terms, you only have to have the same index. Let's look at an example. If I have the square root of 8 times the square root of 2, I can multiply them. The index is 2, index is 2. If they have the same index, they can be multiplied. 8 times 2 is 16. Therefore, the square root of 8 times the square root of 2 is the square root of 16. And of course, the square root of 16 is 4. Let's look at another example. We have the square root of 2 times 4 times the square root of 6 minus 2 times the square root of 3. Now if you have a factor outside the parentheses with two or more terms inside, you multiply each of the terms inside by the factor that's outside. So I'd multiply the square root of 2 by 4 times the square root of 6. I'd multiply the square root of 2 times a negative 2 times the square root of 3. So doing that, just bring down the 4 because I don't have anything to multiply with it. It is out from another radical. But I can multiply these two radical expressions together. Both of them have the same index. 2 times 6 is 12. So the square root of 2 times the square root of 6 is the square root of 12. And I distribute over the subtraction. And I would have, just bring down the 2. The square root of 2 times the square root of 3 is the square root of 6. Now we're not through, because square root of 12 can be simplified. I need to break the square root of 12 into what is the perfect square and what's left. So we have the 4, and 12 is factored into 4 times 3. So the square root of 12 would be the square root of 4 times the square root of 3. 4 is a perfect square. And I cannot factor 6 into a perfect square. I can write it as 2 times 3, but neither 2 nor 3 are perfect squares. So we have the 4. The square root of 4 is 2 times the square root of 3 minus 2 times the square root of 6. Then multiply the 4 times 2 because they're both out from another radical. They're just both numbers, so they can be multiplied. 4 times 2 is 8 times the square root of 3 minus 2 times the square root of 6. And that would be the answer. The terms cannot be combined because in order to combine the radicals, they must be alike. To be alike, they must have the same radicand. This one is 3, that one is 6. Let's look at a couple more examples. The cube root of 2 and the square root of 3 cannot be multiplied. So I cannot do this multiplication. The reason I cannot do it is the indices are not the same. Here the index is 3, here the index is 2. So they cannot be multiplied. Let's look at the cube root of 2x times the cube root of 4x squared minus 1. I can do the multiplication here. Again, I have to use the distributive property. So distribute these, and I'd get the cube root of 8x cubed. 2 times 4 is 8. X times x squared is x cubed. Distributing here, I have the cube root of 2x. So I distributed my multiplication over the subtraction. Now I can simplify the cube root of 8x cubed. The cube root of 8x cubed is 2x. I cannot simplify the cube root of 2x. So I'm left with 2x minus the cube root of 2x as my answer. Let's look at another one. 4 times the square root of 3 minus 8. 2 times the square root of 3 plus 1. Now this should remind you of multiplying two binomials. To multiply two binomials, one can use the FOIL method. first, outside, inside, and last. We can do the same thing with radicals, because as I told you, the process for adding, subtracting, and multiplying radicals is very similar to that for polynomials. So if I use the FOR method and multiply the first two terms together, I'd have 4 times 2 is 8. The square root of 3 times the square root of 3 is the square root of 9. So this would be the first two. Multiplying the first two together. Now I do the outside. 4 times the square root of 3 times 1. 4 times the square root of 3 times 1 is just 4 times the square root of 3. So that's your outside. Now I do the inside. A negative 8 times 2 is a negative 16. And then I have the square root of 3. So negative 8 times 2 times the square root of 3 is a negative 16 times the square root of 3. That's your inside. Finally, I do my last. A negative 8 times a positive 1 is negative 8. Now I take any roots that I can. I can take the square root of 9 to get 3. So we have 8 times 3, and I copied everything else exactly the same. I'm going to multiply, and I have 8 times 3 is 24. I copied everything else the same. So we have 24 plus 4 times the square root of 3 minus 16 times the square root of 3 minus 8. The last step is to combine like terms, or like radicals. Now 24 and negative 8 are alike because neither of them have a radical. 24 minus 8 is 16, and then I can combine the two that have the square root of 3. These are like radicals. They both have a square root of 3. So 4 plus a negative 16 is negative 12. So my answer would be 16, subtract 12 times the square root of 3. Let me give you one more example before I give you another set of exercises.